So for the speaker, he's a consultant at IME Group of Company. Speaker has extensive experiences in preparing CAD and CAM model. It is utilizing CATIA V5. So in addition, he successfully gone through a comprehensive training in advanced machining in aerostructural components in Gifu Prefecture in Japan. So he's also assist a few local companies in machining, such as Edge Group, Sindram Berhad, Composite, CTRM Composite, working on several machining companies in United Kingdom, preparing for CAD and CAM programs for aerospace industries, such as Eurofighter, as well as for big names in motorsports industry, so such as Aston Martin and Ford Washington. So recently, this trainer has associated himself with Nadi Euro Consultants and Rambahat to deliver machining project for UMV Aerospace and SME Aerospace. So this speaker also just completed his PhD in machining of aerostructural composite material, focusing in cutting-tool geometrical design. He's also a registered chartered engineer in Institute of Mechanical Engineering, IMEC UK. He's also a professional technologist, honorary Malaysian Board of Technology and Board, and graduate member for the Board of Engineering Malaysia, BAM, and an Institute Engineer Malaysia, BAIEM. So ladies and gentlemen, I would like now to introduce you technologist Dr. Shahrul Azwan Sundi. So let's hear from him and his experience and view on the CAD, CAM, and advanced machining integrated system in aerospace and automotive motorsport industries.
Thank you so much, Mr. Chairperson, Muhammad Shafiq. Thanks a lot for the introduction. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon. So first of all, I would like to acknowledge Technologist Hafizuddin selaku ketua program dan juga of course yang mana yang saya ni je lah of course Technologist Haiful juga. Alright, thank you so much for the opportunity given. Of course, the rest of the audience for today, and I understand that today there's going to be tiga program, and there's going to be three different programs that attending this event, and then hopefully we can have some benefit from what I'm going to share today. And before that, I would like to apologize myself because of baru baik batuk ni kan. So suara pun macam bass sikit. So hopefully boleh dengar lah. Boleh dengar lah. Alright, without further ado, I would like to, alright, thank you, Resident. Alright, without further ado, I would like to proceed with my sharing, insyaAllah, for today. And kita just santai-santai je lah for this petang ni kan. Okay, I would like to share my screen before I proceed further. So this is a little bit background. Screen dulu, share sound. Alright. Okay. Alright. Can you see my screen at the moment? Clear? Boleh nampak screen saya?
Clear.
Alright, thank you. Okay, just a brief about the company. So basically, this saya beritahu lah my background a little bit kan. Sebenarnya saya tak jauh lah daripada all our colleagues for today. So partly saya juga berkecimpung in education in academics. So later on probably I can brief myself a little bit on that. So before that, I would like to introduce partly of company that I work with as a consultant. Okay, selain daripada work as permanently as education or educators or lecturers, saya juga involved actively with the various company in Malaysia lah. So yang mana kita support, what we can support, especially on academics point of view. So we have to do our best in order to support our industry nowadays. So one of them, Mawia Industries, which is one of the IME group of companies. Yang mana I've been working with Mawia before that, especially Ms. Kashin, since 2009, throughout supporting one of the, I would say that main software that provided by them or supplied by Mawia, which is CATIA V5. So I'm not really sure FTK, UTHM, especially program yang ada hari ni, boleh saya tahu ke software yang pakai SolidWorks ke, pakai CATIA ke, anyone? Atau pakai ada software ke? Ada siapa-siapa boleh bantu? Ada ke Mr. Chairperson boleh bantu ke?
Currently we have SolidWorks.
Alright.
Untuk
Thank you,
safety
Mr.
kita ada apa yang saya tak ingat. Adalah software buat safety. Katia I don't think mungkin ada lah Katia.
Alright. So the main software will be SolidWorks lah. Okay. Alright. Thank you. Okay. Alright. Just roughly about the IME. So we just glide through. Alright, the main software that brought by IME, especially one of the sister companies, Mawia Industries, is CATIA. So of course, CATIA as well as SolidWorks are two main softwares from the subsystem fronts. So basically, we know these two main softwares have been using by various companies in Malaysia. So that's why. Even in curriculum itself, so we have embedded this kind of software to ensure that our graduates or our students nanti bila dah keluar nanti boleh work with the company that yang memang dah pernah pakai this kind of software. So basically, this is a rough explanation, a rough briefing about Mawia Industries. So basically, more or less lebih kepada, I would say that the subsystem partnership, if you look at in Malaysia, there are a few, there are another two companies if I'm not mistaken. So, but the difference between Mawia or IME group with other two is like the appointment of partnership based on the subsystem and Mawia or IME group since 2013. So that's why even me myself, I've been dealing with Mawia for a few years, especially bila kita ada direct program dengan Mawia or with the worldwide punya company juga kita deal with IME. Alright, so that is a brief about the company lah. So basically all this solution we can actually browse through Dassault System solution website. So this is the main, I would say that product of CATIA, Mawia or IME group of company. All right. Okay, so for today, I would like to introduce myself just a little bit. What have been introduced by Mr. Chairperson tadi tu. So in I would say that in other way, partly saya juga adalah seorang pensyarah juga. So I'm a lecturer, one of the faculty dekat UTM, so FTK-MP, more or less like FTK UTHM. So lebih kepada engineering technologies, involved in machining and CAD/CAM for the past 11-12 years before this. So alhamdulillah, so with this collaboration, I would say that we can have a further collaboration later on with FTK UTHM, hopefully. Alright, just a brief about the topic. Saya mungkin Dr. Khairul tadi mungkin saya tak go just a lecturing, more or less like a sharing. I would say that lebih kepada perkongsian. So what we're gonna see the real industry experience that I have gained so far, mungkin boleh boost some, boleh inspire some of adik-adik yang ada dekat dekat UTHM untuk teruskan motivation untuk terus belajar, because what we have in current situation in Malaysia, because we are in the implementation, I would say that executor. So kita execute all those ownership from overseas, for example, like macam kita ada Intel, for example, like kita ada kat even kalau aerospace ni, Boeing, Airbus punya suppliers or vendors memang banyak di Malaysia. And then we are the one that execute semua parts before we send it back to the origin. For example, like Seattle, Boeing in US, so kita akan hantar balik all those parts. Once we have machine, once we have completed all those processes, especially involved in manufacturing processes. So that's why peluang, I would say that the job scope or the prospect in Malaysia ni amat luas. So you have to take this opportunity, belajar betul-betul, because what you have in the curriculum basically does suit to the current demand industry out there. All right. I would like to start with a simple punya video. Boleh dengar tak dia punya sound? Alright. So this is application of CAD/CAM nowadays. How complex the design, or how complex the design can be realistically proven dalam machining. So kita tengok sama-sama lah. So this is Scott Rim from Open Mind. This is the design, dan dia tengah buat the tool bar. This is the simulation. It's a full simulation of kita panggil machine simulation. What we can have here, this is the real simulation. Ini real machining lah. So ini adalah turning. So this is a machine of milling and turning. So mill turn dalam satu machine. This compact machine, part of compact machine. Dia tengah buat turning ni tengah buat turning before the 5 axis simultaneous comes in. In turning position, tengah buat turning lagi with the dekat main spindle ni ada turning punya hook. We're going to turning punya control. Right now, it's going to proceed with the milling. This is the milling process. And this is simultaneous 5 axis. Alright, so this is all the G codes reached by the controller. So the controller put okay, this is more or less like semi-finish, and then turn it round for the second punya pitch sebelah belakang pula. Okay, high performance turn. So this is not a simple punya this is complex this machine. So this is high speed machining of turning to one outside. Alright. So for those in machining and siapa yang ada soul in machining, basically we can actually appreciate the beauty of machining of this part lah. Senang nak machine this complex part. This is the reason kenapa saya tunjuk yang ini. Later on I will try to share and explain later on. Okay, so dia dah start to match with the other side. So kita tengoklah the setup and everything. So kalau kita salah setup, it's gonna be total waste of this part lah. So that's why the cutting technology and the cutting planning is very important. Bukan sekadar on the CAD and CAM sahaja, but we have to have everything in place before we can proceed with the final machine. This is 3 axis simultaneous turning. Turning kita tahu ada 2 axis, X dengan Z. So dia ada simultaneous turning kat situ. So this is 5 axis simultaneous motion. So, macam mana cam tadi kita boleh translate into the real machining. So that is the technology yang ada lah. So that is the current technology yang ada, yang very important. We have to absorb this kind of technology so that we are going to be far with the industry lah. This is the final part. Gila Alright, so that will be our a brief intro. So how the CAD/CAM complex machining involved in the current punya industry lah. So that is a part of OpenMind, one of the software solution in the world lah yang famous, right? OpenMind ataupun Hypermill dia punya software lah. Okay, let us slowly dive through a little bit, kita panggil boring part lah, tapi saja kita go through a little bit on this, so later on probably baru kita tengok lah here and there, just a sharing lah, brief punya sharing daripada saya lah. So probably boleh lah sikit sebanyak untuk nak tengok the reality dekat luar sana So what we have seen just now, so basically the CAD system nowadays is very important. No matter what, semua dah involved in the CAD. If you really go outside there, kita dah tak ada lagi lah direct kita panggil brainstorming with the 2D drawing. So most of the company out there semua dah pakai 3D punya kita panggil brainstorming, and it's very important to get to know the CAD system, and whatever CAD system that you have, the tool itu hanyalah adalah tools sajalah. Whether you have SolidWorks in-house, ada yang Inventor, ada Katia, there are various name of software out there, itu tak ada masalah. Yang paling important adalah how we manipulate, how you can actually use the tool that you have untuk propose ataupun untuk design, untuk create a good design lah. So from the design stage, the CAD is very important. So computer aided design is CAD. What we call it is compulsory nowadays. Before we can actually jump into CAE ataupun CAM yang ada lah. So typical tools, tolerance analysis, mass property calculation, finite element, ini semua boleh buat melalui CAD system. Then of course we have in our case for today, we are going to look into CAM sahaja, not the CAE, but this is a kind of I would say a package. So we have a CAD, CAM and CAE, and this is part of the demand in industry out there nowadays lah, sekarang ni lah. So mana-mana pun semua akan letak kind of criteria kat situ. If you have like a certain software punya skill, that will be the additional or bonus for you to jump into that particular industry. And then we have the CAM, so computer aided manufacturing, lebih refer kepada machining. Although some of the computer aided manufacturing, it's referring to the certain part of, contoh lah macam kita abrasive water jet AWJ adalah part of the advanced machining, how you create the program for AWJ. So basically tak perlu nak create a complex CAM. Basically DXF or DWG, from what you have designed, you translate into the drafting or into the drawing. You can actually bring or transfer into the water jet lah, AWJ punya machine. So basically over there is kind of program tu dia akan automatically generated from the drawing or from the lukisan yang telah kita buat lah. 2D will do. So this is also applies for laser cutting. Alright, so part of the advanced machining, selain daripada AWJ, abrasive water jet machining, we also have laser cut kan. So laser cut also acceptable lah. Maksudnya yang melibatkan 2D saja, XY saja. Z is not really related on this kind of machining. Dia tak berapa kompleks. Tapi dalam machining, especially melibatkan CNC milling ataupun turning, so definitely you have to define the own way how to machine the part. So that's why it depends on how expert you are, how good you are. So that's why in order to put everything in the CAM system, so you have to be a very good practice person in the shop floor before boleh pergi pegang mouse untuk buat benda-benda macam ni lah. So that's why kena ada knowledge and experience being in the shop floor dululah sebelum kita boleh buat the CAM system. So that's why CAM ni semua bergantung kepada programmer. So some of the position out there, they call it as a CAD/CAM programmer, some CAD/CAM engineer. Ada beberapa company yang saya dah visited before this, they call it CAD/CAM engineer. Why they put it the engineer? Because of you have to have kind of knowledge untuk buat improvement. So that's why semuanya depends on kepada programmer tersebut. So that's why CAD/CAM ni pun dah jadi part of the engineering punya position nowadays. If you look at over here, a little bit on dia macam history lah kalau tengok 1970s, manual paper drafting, and then baru masuk 2D, baru masuk 3D, and now it's full digital prototypes. So basically kalau kita tengok kat sini, the latest I would say that 3D experience product, a new product from the subsystem, you can have a system engineering simulation. So before you can do the mock-up atau membuat prototype and so on, semua the system can be embed into the software. So bila buat for example like kereta punya simulation and so on, we can actually know from the software itself. So that's how powerful the software nowadays. Even before this, we have listened to speaker number 1 tadi, Cik Mazlan, also related to what? CFD, computer fluid dynamics. So it depends on the simulation before you can go into the reality, or else you will actually incur a lot of costs over there. So that's why simulation is very important nowadays. But then dia adalah it's just trusted punya kita panggil the validity, the validation of validity of the data from the simulation nowadays is very kita panggil very helpful lah dalam buat certain punya product. Alright, so this is show the important lah the CAD model. So CAD model ni how important it is, dia boleh relate to the CNC manufacturing, even we call it IR 4.0 nowadays. One of the element of IR 4.0 whatever, the 3D printing ataupun additive manufacturing AM. So one of the element also related to the CAD model. So tak dapat tidak lah So kena juga belajar, and you have to make sure that you are well versed in manipulating in utilizing the tools given to you. Kalau kata SolidWorks lah, belajarlah bagi elok. Automation also related to the CAD juga, kena ada the CAD system. Once you have assemble everything, and then you can simulate before you can actually generalize ataupun kita buat the reality of the product. And the rest of it lah, simulation analysis, what we have listened before this juga adalah part of the analysis. Sebelum kita buat macam Cik Mazlan beritahu tadi lah before you actually go through all those ducting design, so you have to simulate before boleh tahu berapa the sizing and everything, berapa dia punya loss and apa semualah, dan barulah kita buat kepada the real fabrication. So that's why this system is very important. This is downstream benefit, maksudnya pada CNC, rapid prototyping. So if you get over here, nowadays ada banyak there are various type of rapid prototyping available in the market out there. Even kalau sekarang kita kata commonly lah, FDM, fused deposition punya method ada yang famous lah, and then kita ada juga yang quite complicated dan quite kita panggil lebih, it's more accurate as compared to the FDM, the SLS, laser sintering punya rapid prototyping, which been used by banyak yang digunakan oleh Dyson to validate their prototype or the design, adalah SLS method. Even here we have a few lah, ada yang liquid type, powder type, ada banyak. Semua where it's come from, the source is actually from the design, from the CAD design. And then the system will actually follow apa yang telah kita, what we have created, what we have defined dekat dalam sistem tersebut lah. So that's going to be akan di-generated by the system. Alright, 3D downstream benefit. So ini pun sama juga benefit ataupun kita panggil the advantage yang kita dapat from the CAD and CAM system. Okay, ada banyak from the CAD system lah. Simulation analysis like I mentioned just now. So kita ada stress analysis, boleh juga buat dynamic analysis, boleh juga buat kita panggil static analysis. So like what we have mentioned just now, jadi apa, pakai abacus. Abacus is one of the finite element punya software lah yang quite NCS juga salah satu software untuk finite element. In fact dalam KCA itself pun kita ada semua lah yang mana related to it's a complete solution of CAD, CAM and CAE. Alright, so basically just a brief about machining. Kalau once kita dah ada all those the CAM system, CAD and CAM system, then of course we have to have the knowledge of machining before you jump into the machining. So kena ada this kind of kita panggil knowledge dulu. So kalau tak, how can you produce a good program? Even kalau kata the exit itself pun you're not well versed. dalam orang kata apa, tak begitu tahu tentang axis machine tersebut. So we have to understand the fundamental of the machining first. So this is a partly what we have over here. We always have a normal 3 axis, or mungkin ada yang right hand rules, mungkin ada pakai left hand rules, ada X, Y, Z. Then on top of that, if you have a complex machining, macam mana boleh pergi sampai 9 axis, 9 axis, 7 axis. So it's not actually 7 axis will run simultaneously. So far yang saya involve lah, pernah lagi yang 7 axis tu bergerak dalam satu masa menggunakan satu head lah. Normally it's different head. Okay, so dia ada combination tu semua. It's because of the complexity of the part nowadays. So hari-hari kita tengok parts makin complex. Tak ada lagi lah. For example, like we try to look into the Volvo nowadays. If you compare the current Volvo design as compared to the previous like 10 or 15 years ago, tengok dia macam kotak aja kan. So nowadays it's very slick design. So how to produce that one? That is the challenge of engineering. So that's why it comes with a complex punya machine, complex punya processes nowadays. Nak support lah, in order to support the final punya production. Right, so basically this is the axis lah. Kita ada X, Y, and Z, and then kita ada some called Z, European called Z, X, Y, and Z, and then ada A, B, C. A, B, C will actually rotate along X axis, along Y axis, along Z axis. So this is kind of rotation yang kita ada additional rotation yang memberi kepada flexibility. All these rotary axis improve the flexibility of machining. So that's why dulu kalau produce a certain micron, now the requirement getting stringent lah. Dia lagi kecil dan lagi controllable punya precision tu lagi halus. Ini juga saya just nak share lah. So when we call it 5 axis, nanti bila pergi nanti during the interview, for example, so have you heard before this is 5 axis machining? Pernah dengar 5 axis punya machine? Oh pernah kan? Pernah dengar. So what is the difference 5 axis and 3 plus 2? 3 plus 2 sama dengan 5 juga. And 5 axis 5 juga. So what are the difference between these two? Okay, sebab ada yang especially like our situation in our government situation, especially related to the tender. Memang kadang-kadang ada related to this punya issue lah. 5 axis simultaneous machine is not the same with 3 plus 2. Okay, in machining, when we call it 3 plus 2, bermaksud dia bukan simultaneous machine. Memang dia boleh bergerak 5 axis but not in one block. So that machine, that particular machine is not able to move 5 axis simultaneously. Jadi harga dia akan murah sikit lah as compared to 5 axis simultaneous. So itu beza dia lah. So dalam 5 axis complex machining ni ada 2 jenis machine yang mana ini adalah what we call it the current demand nowadays lah. Bila 7, 9 and so on tu adalah additional sahaja. So when you're talking about simultaneous or multi-axis machining, kita ada maximum lah, kita ada so far adalah 5 axis punya machining. Yang mana dia boleh bergerak 5 axis dalam satu masa lah. Yang ini beza dia. So please look into the right machine if you are required or you are asked to buy a certain machine for your own product. For example, like ada new project coming in, so that particular product or that particular part number need to be machined by using 5 axis simultaneous. Please look into the full 5 axis simultaneous machine, not 3 plus 2. Kadang-kadang bila kita tengok 3 plus 2 harga 500,000 murah daripada yang ini, for example. So then kita straight away kita beli yang ini, tapi sebenarnya kita tak dapat the full spec lah of that machine, and that machine is not capable to do yang semua yang surfacing punya machining dia tak boleh buat lah. So just a sharing lah kat sini. Yang lain-lain ini adalah antara yang famous lah. So this is famous. Kalau dekat UTHM ada machine apa dekat sana, boleh kongsi dengan saya ke? Dr. Khairul ke? Special ada?
Sodik, kita guna sodik.
Oh sodik untuk even milling pun pakai sodik?
CNC dia brand
sodik untuk wire cut lensing ke?
Wire cut dengan lensing. CNC brand Taiwan Korea. Student boleh ni, ingat tak?
Siapa-siapa boleh tolong? Kalau kata yang banyak brand sekarang ni, macam-macam jenis brand. Ada yang OEM brand pun ada untuk 5 axis, macam-macam. Itu yang brand-brand semua ni adalah macam kita beli kereta lah, janji kita boleh jalan kan. Beli Mercedes ni, yang ni Mercedes lah. Jadi maintenance pun esok Mercedes punya maintenance juga So this is all the what we call it the famous brand lah in the world, I would say. Because kalau di MG Mori ni, before this the MG control Europe punya market, and then they merge dengan Moriseki from Japan. Now they are trying to conquer the whole world dalam machine tools. Machine tool lah. Hamler pula is a good punya machine from German. Then Masa as we know.
Kalau CNC kita Washon, Taiwan.
Oh, okay.
Washon.
Okay, thank you. Okay. So tak kisah yang apa-apa brand pun, yang penting dia punya konsep tu is gonna be the same. Whatever controller yang dia pakai, ISO programming tu sama je. Cuma tinggal lagi macam mana kita nak fully utilize lah the machine yang ada lah. So lagi mahal machine tu, lagi maintenance dia boleh tahan juga lah. Macam kita orang kat sini pakai DMG Mori kat. So we have 7 machine, we have 2 5 axis, ada 1 9 axis, ada 3 axis 2, ada 2+1 turning ada 2. Semua canggih tu canggih lah, tapi ya Allah bila time maintenance pening kali. Alright. So it's a good exposure to the students. So kena ambil this kind of opportunity. Because engineering technology, faculty technology, that is the advantage. The words technology will actually differentiate you between the engineering students, and that will be your advantage when you go out there. Your hands-on punya skill itu yang akan bagi orang kata the big impact lah to the industry dekat luar sana. Alright, so this solution provider. This is all famous punya solution provider. There are numbers of solution provider out there. Tapi tak kira lah whatever yang kita pakai, whether Katia, what I'm going to share right now lebih kepada Katia lah, because I've been using Katia since 2006. So sampai sekarang pun masih guna lah, masih guna, dan dalam kami punya, in our curriculum we have embedded Katia and SolidWorks. A certain program SolidWorks, a certain program adalah Katia lah. Tapi tak apalah, apa juga yang kita punya software, whatever the solution provider that we have, that's only a tool. Yang penting adalah how can we mengguna pakai software tu yang sebaik mungkin. Banyaklah Hypermill and XCAM and various lah. And every single industry, they will have their own preference. Why they choose this software? But the most importantly, I would say, how you can actually Katia ke Hypermill, the concept is different. The concept is the same. Concept machining, for example, like ada machine, ada cutting toolnya, ada cutting planningnya, so ada fixturingnya, everything will be the same. The only thing mungkin icon yang berbeza. So mungkin in terms of how you insert the machine is different, but the overall concept is going to be the same. So that's why company out there, dia akan tulis is a bonus. It's not a must. It's a bonus. If you have experience using this software, for example, it's a bonus for you. Tapi bukan it's a must. Dia bukan must. Sebab dia confident if you have gone through a certain process of using that software, boleh adapt to a new software at any time. Boleh, tak ada masalah. It's not about the software. It's about the concept tu yang dia penting lah. Okay, saya laju sikit lah. Ni advantage apa semua ni lebih kepada yalah, bila dah ada the complex machining ni, especially the 5-axis machining, dia dah boleh pergi kepada 5 sides and 5-sided kan. So lebih in terms of accuracy wise, greatly improve. In terms of flexibility, greatly improve. In terms of price, mungkin kita investment tu mungkin tinggi sikit lah. Lepas tu that will be okay lah. This is another one. In terms of finishing, bila ada 5-axis, when the tilting punya motion tu, dia akan, in terms of rigidity of the machining, also will be improved. Ini adalah the advantage of having multiple or multi-axis lah during the machining. Yang ni disadvantage. So having said that, of course lah, large investment. So you have to have a money in terms before you can actually invest, increase cost of tooling. So might be having a various tooling, various fixture, increase complexity. So the system is going to be more complex. Nak kena ada high skill programmer, kena train dulu. and then and so on. So this kind of investment. So kena big calculative lah before a certain company invest in this kind of 5 axis ni lah. Alright, later on I would like to share with all the audience today just a little bit lah apa yang kita dah gone through, especially me and my team in providing this kind of kita panggil CAD/CAM and advanced machine, especially related to aerospace ni lah. So we are here located very near to the industry, so just surrounded by other industries out there, especially CTRM, Impressive Age, Improvage. There are few companies, especially precision companies yang ada dekat sini. So we have, alhamdulillah, so have managed to conduct a few project lah dengan diorang. So that's where we gain lah, kita gain sama-sama lah. I mean, before we can actually plow back, or before we actually can share with the students in the reality of the machining. So this is part of it. So ini adalah salah satu project juga. It's what we call it is a laminate punya, untuk composite laminating punya fixture. So this is fixture, nak kena buat kind of kita panggil dia panggil trim off lah, skim off nak kena buat skim off. So this is the reality of the machining. So apa yang ada pada CAD system, what you have defined and what we have programmed in the kita panggil CAM system, going to be translated exactly into the machine. So ni kalau fail ni, the whole part ni adalah modification, bukan daripada satu block yang kita boleh beli lain. So kalau kita machine from a single block, from a billet, tak ada masalah lah, boleh beli balik billet tu 7 series ke 6 series ke, and then cuma kita akan bayar in terms of the cost. Cuma kat sini, if you fail, what if we fail this one, so apa akan jadi, we have to bear the whole cost of producing yang ini. Kat sini nampak ada welding and so on. So semua part ni kena bayar. So it's very costly. So in other words, kita boleh kata yang ini tak boleh fail lah. So alhamdulillah. So kita is collaboration between dengan industri. So dia orang akan ada lah waktu machining and so on. So kita pun tak pandai kan. So kita pun we try our best to support whatever things that kita boleh buat, and the rest kita leave it to the company and kita gain together during the machining lah. So that is what happened. Ini juga salah satu, this is from the billet, satu billet yang solid. It's AIDC Taiwan, from Taiwan punya part. Memang aerospace dia lah. It's a door bracket. So ini untuk FAI, first article inspection. So kita machine untuk yang ini. Cuma kat sini, if you look at over here, kalau untuk semua adik-adik yang lihat ni, if you look at over here, the expensive part of this one bukan guna CAD/CAM tu. That is part of it. Kita boleh belajar. Tapi yang it is more importantly adalah the technology, the cutting technology. One piece. Macam mana the whole block ni, how can you machine the whole block to produce one piece macam ni. So in terms of holding punya technology, that's another issue. Macam mana nak hold this part, and how you can hold this part to ensure that the final part will not bulging ke warping ke. So ini yang adalah teknologi yang mahal lah, because of aerospace part ni kebanyakan semua nipis, semuanya yang very thin. So this is less than 3 mm. Nanti yang bawah ni lagi it's about 1.7 mm saja yang ini. So this area is only 1.7 mm. Why aerospace part dia thin, dia nipis, is because of the weight. So that's why dia banyak dia punya part, semua design adalah design yang thin lah. And then most of the design semuanya complex to be machined. So that's why if you jump into the, kita panggil dalam aerospace punya machining, insyaAllah lah boleh pergi ke mana-mana punya industri, sebab you have experienced the most difficult part to be machined, dan pergi masuk automotive, dia akan jadi lebih sikit lah, insyaAllah. So more or less macam tu lah. So it's again, kat sini pun saya tak tunjuk lah, maksudnya this is a part, how can you produce this part from one billet to this. So kena ada the technology lah, maksudnya cutting technology, macam mana nak hold dia, where you want to machine first, when you want to machine last, where you want to actually leave the material, for example, ni tinggal dulu, yang ni yang last, and how to maintain lah, how to maintain the accuracy. Nah, ini semua contoh-contoh dia lah. So this is a part of the CMM, as what you always know, that CMM ni adalah partner to the machining. So once we have machined everything, they will be sent through the metrology bin department. metrology department, they will have a very complicated machine called CMM, coordinate measuring machine. This coordinate measuring machine will actually verify whatever things that we have machine dekat machine tadi tu. Kalau kita pergi sini fail, tak ada maknanya dekat machine yang tadi kena buat lain lah. Jadi yang paling takut adalah dekat CMM lah. So once CMM result keluar pass, dah boleh celebrate lah. Lepas machine, tak boleh celebrate lagi. Kena celebrate dan lepas daripada CMM ni. Ini adalah contoh. So this is a part from CAD system. This is from the CAM system. And then the actual part given to us siap dengan fixture dekat bawah ni. So it's very useful sebab kita boleh guna benda ni untuk kita fix to the table. So senang lah sikit nak buat machining. And then apa benda sepatutnya kita buat yang ni. Ada skim off dalam ni. Dia nak turunkan for example like 3mm ke dalam. So kita kena turunkan. Ni pun sama macam case tadi lah. Kalau salah setting, salah semua, the whole piece ni kena ganti balik. Memang itulah boleh. Ingat dapat untung kan, lalas rugi juga. Bukannya untung. Alright, so itulah, that's the challenge in industry lah. Ataupun the challenge from kita punya side. Especially in education atau in academics kan, kita punya side pun challenge jugalah untuk kita buat the actual punya industry punya part kan. This is another example yang mana kita invite ataupun kita import everything. So this is a table of the machine. Yang ni fixture dia. And then this is the part. Dalam part ni, ni dah ada sikit lah. This is some of the secret lah. Maksudnya part yang kita nak pakai yang ni, di tengah ni. So the billet ni given to us, this is the billet given. Satu billet, satu kita panggil material yang block lah. And then dekat dalam ni ada cutting technology. So this is what we call it cutting technology lah. Ni cutting technology ni lah yang dia belajar kat Jepun tadi tu, yang kita punya chairperson je. Syafiq kita bagi tahu tadi kan. So I've been in Kifu lah, siapa pernah pergi sana. Dan 3 bulan. 3 bulan and balik still. Although I'm from serving as a lecturer, tapi most of the time dealing with the company. So itulah, memang ada project yang untuk aerostructural punya machining dekat sini. So that's why since 2006 lagi lah, so I've been involved with this kind of project lah. So all in all, what I can summarize over here, yang ni yang berlaku dekat aerospace, but having said that, it's actually practicing by every single industries nowadays in Malaysia. Walaupun bukan fully, kita panggil fully implementation of CAD/CAM system, tapi semua dah start pakai. Kalau macam yang company ni, dia lagi orang kata establish kan. So jadi semua programmer yang akan buat lah. So from the CAD given, so this is the cutting planning. So yang ini adalah CAM. So we have to produce the CAM based on the experience or based on the best practice of machining. So kita akan dapat yang ini. And for information, this kita panggil top cut ni only left about 1mm. 1mm in the CAM system. So what happens? So this is what we call it G10 Shaw ataupun documentation. So this is documentation that we programmer akan communicate with the machinist. So in certain company, so you are the programmer, you are the machinist. Kalau company kecil lah. In a established company, for example, company yang besar-besar, especially SAM dekat Penang tepi highway tu kan, Singapore Aerospace Manufacturing, itu memang split. Programmer memang buat program sahaja, and then you have the machinist to load the program and run the program for you. So in order to have a very clean communication between one to another, so you have to have this kind of documentation. So documentation ni penting lah. And then kita ada simulation. Yang ni buat third party punya simulation. This is another, kita panggil mission verification, dan barulah produce the part. And this part produce exactly yang macam ni lah, 1mm, exactly 1mm. So that is the accuracy we can achieve by today's punya CAD/CAM punya system. So jangan kita ingat main-main lah dalam CAD/CAM tu. So everything that we put inside there, dia akan translate 99% I would say. Kalau bukan 99.98 lah, 92% tu kita leave it to the physics, because physics ada vibration and so on, the cutting tool, everything. So that's why kena be careful lah. So ni antara the recent punya project lah that I have involved with SNDA before this, yang sama juga. So we have this one. So kita ada yang ini, translate into the CAM, and then this is something different. Kalau sebelum ni semua tengok CNC semua vertical, but this CNC adalah horizontal. Dia punya head dia melintang, bukan head dia duduk menegak lah. So jadi to program this one slightly different tapi not bad lah. So ini kita dapat nampak yang kita panggil yang dia punya block lah, the whole block yang macam ni baru nak start roughing ni basically. So ni ada 1, 2, 3, ada 3 lah, 4 yang bahagian atas ni. Dia punya top surface ni. Ni this is how tak habis lagi ni. Basically it's not finished yet sebab ada lagi this section. Tapi more or less dah nak habis. Final kita akan dapat macam ni. So this is a real bus punya part lah. Ini is just a sharing. Although macam Cik Mazlan kat tadi kan. PNC basically. Private and confidential. Tapi for educational purposes, kita boleh share. So this is all the drawing that I have involved before this yang with the team lah. So dengan Rolls Royce, I've been involved with Rolls Royce dengan casing engine casing punya part pun pernah. Dengan Airbus, dengan Boeing ni boleh kata banyak dengan yang inilah sebab yang ni yang banyak. Yang lain pada tu ada Embraer, Bombardier, apa semua lagi lah yang kecil-kecil atau orang kecil-kecil. Yang ini banyak tolong-tolong banyak bantu-bantu all those kita panggil supplier ataupun vendor. Ini salah satu contoh lah. So this is one of the Aerospace Composite Malaysia ACM. Is a vendor of Boeing. It's been bila ni 2000 sebelum PKP saya sini. So I've been invited to be a speaker untuk ada 24 orang tak salah saya, semua sekali dengan dia punya senior engineer semua ada. Just a sharing macam mana to machine a composite part. So tadi tu talking about metallic. So this is composite part. Composite part lagi challenging is because of dia punya behavior is different. So ini sekadar perkongsian lah, maksudnya once kita dah gain something, the sharing tu buat kita jadi satisfaction lah pada saya, it's a puas hatian. So ini located dekat far away dekat northern region, dekat Bukit Kayu Hitam. It's a huge company, memang Boeing punya, kalau tak salah saya dia ada tulis ni. Right, a joint venture of the Boeing company and Hexcel Corporation. It's not a Malaysian company, it's a overseas company. Used to be Malaysian, tapi tak salah saya dah dibeli oleh Boeing dengan Hexcel. It's an interesting experience. Ada beberapa training lah yang buat dan beberapa project. In fact, still ongoing dengan this company. Boleh lah, sebab dia orang pakai Katia. So, dalam aerospace ni banyak pakai Katia. So, adalah yang boleh kita kongsi-kongsi. And untuk pengetahuan semua, for the audience, for all those members of the floor, yang machine belakang saya ni, so this is the largest machine, the largest CNC in Malaysia. So this is 15 meter, 15 meter CNC machine. So paling besar lah, tak ada lagi yang paling besar. So far yang paling besar dekat CTRM ni pun baru 8-10 meter. So this is 15, just recently acquired by them untuk panel yang 777 ni. Ini besar, tapi ini composite. Ini composite. Ada dua lah dalam aerospace. There are two main structures. So the first one metallic. Was involved in metallic before this. Baru-baru ni je lah baru involved dengan kita panggil composite lah. Ni semua young engineers ni. Train all the young engineers yang baru graduate from RMIT pun ada ni. Balik daripada Australia. Ni yang local. So this is a company, it's quite huge punya company lah. Dekat Bukit Kayu Hitam. Just a border. Ini another training on the Siemens punya simulation. Kita panggil controller. Controller dia banyak pakai Siemens. So jadi what I have shared to them is controller punya ni lah. So this is another mission. Kalau tengok adalah ni boleh main futsal. Alright, so ni orang dia duduk jauh tu, kita duduk kat depan ni. So we can actually play futsal inside here. So huge mission lah, CNC yang besar. And then semua 5 axis lah. It's all a 5 axis machine. Ini adalah from CAD system. This is a CAD system. Whatever things dan kita translated, if you look at over here, semua yang putih-putih ni, semua point-point ni, ini adalah drilling. So this is holes. Involve more than 350 holes dalam satu panel. This is composite panel. So banyak drilling yang berlaku. So kalau kita boleh save satu hole, boleh save 2-3 saat pun, it's meaningful for them untuk improvement. So jangan ingat kita tak boleh buat something tau. Pergi kilang nanti cuba to improve, try to improve. Even 1 second pun orang berkira lah, maksudnya something yang ni lah. Ini yang dengan SMEA lah. SMEA more to metallic, besar-besar jugalah. Tapi itulah just pengalaman, just kongsi. Kalau tengok sini sampai malam, sampai pagi. Ni pun zaman-zaman COVID juga. So pergi sana, involved with the machinist, duduk bincang and so on, and program. So this is their program, workstation. Bila dah berlaku tu seronok lah, tapi time nak jadi tu memang ni pukul 3 pagi saya tak balik lagi ni sebenarnya dekat kilau. Ni ada gambar tunjuk jam tapi ni tak adalah dalam ni ni lah member dah tidur lah nak. Tunggu lama sangat ni member dah tidur, saya tak tidur lagi. So part dia besar lah. So this is part of the, kita panggil pengalaman lah, some of the experience. Sebut tak lah banyak ni 5 minit je. Right, saya just proceed je lah. Tak banyak ni, just a sharing je. Yang ni just an example, what we call it, kita orang pun as U-Time kita ada juga Formula Varsity, and we produce this in-house. Kita panggil knuckle So knuckle ni dipasang pada kita punya FV. Tak tahu bila FV nak ada balik lah. So this is, if I'm not mistaken, last few years back ni, 2014, 2015 saya tak salah ni. And then sport rim tadi kita tengok sport rim in the YouTube. So basically, alhamdulillah, biiznillah, dengan izin Allah, we have managed to produce our own 16 inci punya sport rim with the project with Mimos. Mimos ada request dengan kita untuk buat this sport rim. This is a real punya, kita panggil story, saya boleh share lah. So kita produce daripada cam, ni memang model designed by the engineers by Mimos. And then this is a cam punya simulation. And then this is from the simulation of a controller. Kita pakai Siemens 840D. And then this is how we load the material 5012 aluminium 5012. Kalau seorang tak boleh angkat lah ni very kita panggil berat too heavy lah for one person to lift this material. And that's why we have to have this one. So, sebab lab tak ada kita panggil tak ada overhead crane And then this is what we call it the step, kita standby untuk kita climb there from the bottom, and then we have the roughing punya process, and this is a semi-finish. And then we have, although dalam video tadi what we have watched just now adalah dia adalah turn mill atau mill turn machine. So we managed to produce by using only 5-axis milling machine, but we have improvised a little bit on how to perform milling by using turning punya process. Macam mana nak buat tepi ni? So kita ada some secret lah before we can get this clean finishing and shiny. Ada cool video. And then this is a flip over. So once we flip over, then we have managed this one, and this is very very important. Sebab kalau kita salah letak and salah kita plan, the whole piece will be scrapped sebab tak bertemu yang dalam ni, yang belakang dengan yang atas. So once not match tu memang definitely kita kena scrap lah. So satu material pun dah 45,000. So alhamdulillah yang ni one piece lah. One piece kita boleh manage sampai habis lah. So this is a video a little bit sikit lah. Laju lah So this is a 5-axis punya motion lah. Simultaneous 5-axis. Alright. So yang bawah ni adalah during roughing. So roughing satu yang tu kapan itu yang very long tu yang ada special. Alright, so this is the actual punya machine. Alright, yang ini very very important lah bila tengah potong. Macam tadi saya cakap, I have mentioned just now, when we flip over the other side, kita nak buat yang ni, tunggu dia bertemu ke tak. If this one is not matched with the spoke dekat dalam tadi, the whole piece will be scrapped. So this is a very important moment lah. So dalam this case, alhamdulillah, saya dia dah bertemu, so which means the cutting planning, the setting, the setup and everything just nice. Alright, so this is finish by machine. Tak ada lagi, belum lagi ada proses kita panggil polish ke apa. Tak ada lagi polishing and so on. So this is finish by the machine. Okay, so ini part dia lah, ini machine belakang dia. It's a 5-axis machine lah. Yang lain ni je saya laju lah. This is also a part of the automotive punya project juga. It's a brake caliper. It's a hard punya material. Cutting planning very important. Kita dah buat satu scrap sebab kita salah setting. Last kali tak dapat, and that we have learned from the mistake lah. And then the final part baru kita produce lah, the actual part. Ini saya just go through just a brief punya experience lah yang saya gain dekat overseas. Mungkin boleh boost up adik-adik dan rakan-rakan semua lah yang ni kan. So kita based on the experience that we have here, insyaAllah boleh lah kerja kalau pergi overseas tu kan. Ni saya dapat peluang lah untuk kerja dekat one of the company in Southampton. Waktu sambung belajar kan. Rumah saya yang sambung basically, saya pergi kerja. So ini buat untuk yang tadi tu Ford Racing punya team. So this is casting punya part. So it's casting and then after casting detailing. So detailing tu lah yang nak kena buat machining. So this is the machine yang diorang ada. It's a Herco machine, my best friend. So this is Birmingham. Sama juga macam kita Metal Tech. So ini yang dekat tadi lah. Saya just share ya. So macam mana the cutting planning, the fixture. So you have to design the fixture. And you have to remember this is a casting part. So casting part, the accuracy is very susah nak control. So that's why in order to produce the fixture juga kena ada kind of technology lah. Kena ada teknologi lah. Then only we can actually use the same one. Ini how to produce from yang macam lasam ni kan. Okay, they all tak ada CAD model. So what I need to do is I have to translate this drawing into the CAD model. So from the CAD model, then only baru kita produce the machining pun boleh juga macam-macam kerja lah sana macam-macam kerja buat. Ni pun sama juga machining banyaklah relate dengan machining, and this was my boss during the time. Waktu snow pun kena pergi kerja juga, snow tebal pun kena pergi kerja juga. So kind of experience lah. So ni direct punya boss, saya report direct dengan dia macam Bruce Willis sikit lah, nampak kan. Just a sharing je lah. This is a different company, buat kind of macam cutting planning juga kat sana. Ni pakai smart sikit lah, duduk dekat production kan. Duduk dekat design punya room. Ni antara yang ni lah. Yang lain tu saya just browse tu je lah, masa tak mengizinkan. Ini antara yang project dengan Petronas. So it's a very hard punya material, and then if you look at over here, kita hanya hold 3mm by using this cutting technology punya fixture. Ni lang daripada Jerman, and then very very hard material. Ini nak potong roughing saja 6 batang cutting tool patah bukan patah, one. So basically the cutting tool punya teknologi tu penting. So it's our mistake lah, kita guna solid by right is guna insert. So yang menggunakan ini adalah guna insert lah, the best punya approach. So ini from Katia, ini from Head and Hine simulation, ini adalah from actual machining. So what we can see over here, the similarity, the alignment between one to another. So dalam kata lain, what I would like to mention, benda ni penting lah, dalam camp pun penting untuk kita make sure that semua akan translate more or less like 98-99% like what I mentioned tadi tu lah. Ini pun sama juga, the teknologi that kita machine daripada site ni just go to a quick one. It's very slow motion because it's very hard material. Yang ni something good kita bawa the motor and everything inside the lab, dan kita buat kita panggil pre-validation kita validate dulu sebelum kita buat the other side. So once kita dah buat the other side, dia masuk balik, and then kita buat simulation lagi, and then baru kita buat the final finishing, and this is the final assembly. And now benda ni dah ada dekat port lah, dah ada dekat port, dia panggil gangway ada dekat port. So benda ni tukar katanya 8-10 tahun sekali. So that's why dia perlukan material very very hard. HRC dia 60. Siapa yang tahu hardness 60 to 70. Memang betul-betul 60 to 70. Ni HRC. Yang ni sharing jugalah. So this is part of the milling, tapi kita buat macam training jugalah. This is a rocket launcher. Ini trial untuk new design. So this is the machine. Lebih kurang macam tu lah. So lebih kurang aku ni geng-geng satu lab lah tu. So ini kalau kita tengok ni, what we can see over here, dia punya finishing lah. Sama apa yang ada dekat cam ni. This from cam, so this is final one. So dengan UPNM this one, this project. So I guess yang itu je kot. Dah lebih masa kot Syafiq, sorry about that. And then yang lain ni adalah video je lah. So dah itu saja kot for me. That's all from
Alright.
myself for today. Alright, thank you.
Oh, that is delicate presentation that you have given, Mr. Technologist Dr. Shahrul. I'm very honored to learn new things about this. So I think we can ask a few questions here. We will open the chat for question. So from Shamil Hakim, down in comments, he asks, why do tools are in horizontal axis
Okay.
for the
Shamil Hakim. So can I just straight away answer the question? Okay, basically boleh saya jawab terus lah kalau kata ke nak tunggu yang lain-lain.
It's okay. Go ahead.
Alright, okay. So thank you, Tarikh, for the question from Shamil Hakim. Alright, so why the tool exists is horizontal? So I guess Shamil is actually referring to this part, if I'm not mistaken. So I just try to get the slide back. So is it this one that we have? So if you look at over here, like I mentioned just now, so in CNC, there are two types of kita panggil configuration, machine configuration. So we have the vertical type of configuration, and we also have the vertical type of configuration. So horizontal dengan vertical. So in this case, so in this machine, we call it horizontal CNC machine. The axis will remain the same. So if you look at over here, so this is my axis. So dia akan sama je. Y, X dengan Z. Z dia adalah pada this position. And then what is the advantage of having this horizontal as compared to vertical? So the main advantage of having this kind of configuration of machine adalah dia punya swath ataupun dia punya chips. So the chips will not actually block somewhere around here once we have machine everything. So once we have like 80%, 80% material to be removed, for example, like in aerospace, most of the aerospace part, there's going to be like 70 to 80% material removal. So what we can get is actually at the end of the machining, the swath or the chips is going to be like accumulate everywhere inside the machine. So that's why by having this kind of configuration, you have a clean cut without any obstruction from the chip. So this is one of the advantage of having this kind of machine. So sebab itulah dia duduk dalam this kind of position. Okay, am I answering the question?
Yeah, I guess so. So I wanna get a chance again to say thank you to Technologist Dr. Shahrul for your insight for presentation.